Our first lesson in Chapter 7 will be about simple interest. Pretty much all of our lessons in this chapter will be about some kind of interest being accumulated or being paid out, and in various different ways. So we're going to start very simple with what's actually called simple interest. This is the most basic type, and you may recognize the formula from previous classes, which is that I equals PRT. Now in this formula, we have 4 different variables. The I represents interest earned. Okay, so this is how much you're actually going to add on to whatever you start with. What you start with is called the principal, and so that's our P value. Principal is also sometimes called the present value in the situation. So if you see that language, it means the same thing as the principal, and that's the amount that we start with. That's the amount that's going to be earning this interest. The rate is R, and the rate is usually given as an annual simple interest rate. And the one thing we have to remember with rate is that when we put it into the R for the equation, we have to remember to write it in decimal form. So it will often be given to us as a percentage, but when we put it into the actual equation, we need to make sure it's in decimal form. And then finally, the T stands for time, and specifically that time needs to be in years. Okay, so if you have any 3 of these 4 values for these 4 variables, then you can always find the 4th one, the unknown one, by solving this equation. But this equation just tells you how much interest you earn. Usually what we're more interested in is what the actual amount is going to be at the end of the time. So we can come up with another formula which tells us A. And A, in this case, is going to equal the amount that we end up with altogether, which is sometimes called the future value. Whoops. Okay, so in order to get the overall amount, we're basically saying that we want to take the principal that we start with and then add whatever interest that we accrue. Well, since we know that interest is equal to PRT, we could actually write this as P plus the PRT that interest is equal to. And actually we could even change that a little bit more, because both of these terms have a P in common. So we could factor the P out and be left with 1 plus R times T in the parentheses. And honestly, this is the form of this amount future value equation that we usually see. So A, the amount that we want altogether, will be equal to P times the parentheses 1 plus RT. Okay, so let's use that in a couple of situations. Here's a simple first example. It says that we want to find the total amount due on a loan of $800 at 9% simple interest at the end of 4 months. So the key to this is right here. The fact that we want the total amount due is an indication that we want to use the future value equation. What is A going to equal? And from what we just saw, we know the general form of that equation is that A should equal P times the quantity 1 plus RT. So let's identify those variables here. We need P, we need R, and we need T. So P is our principal. That's the amount that we're starting with. That is going to be the $800. Okay. The rate is our simple interest rate, which is the 9%, but 9% as a decimal will be put in as 0.09. Now what about the time? Take a minute as we pause the video and write down what you think we should put in for the T value to represent the time for this loan. Now hopefully you realize that we're being told time in 4 months, but back in our last slide we said time had to be represented in years. And so when we set this up, we have to think of what part of a year 4 months would be. So 4 out of 12 is equal to 1/3 of a year, and that's the value we'll be using for T. So when we substitute this in now, we have 800 for P times 1 plus an R value of 0.09 times a T value of 1/3. And now when we plug that into our calculator, we end up with an amount equal to $824. So let's just say it's a friend that's loaned you some money and they don't want to get too complicated about things. You say you're going to pay them right back within 4 months, so they just decide to charge you 9% simple interest. At the end of the 4 months, you would be paying $24 extra to your friend who allowed you to borrow the $800 from them in the first place. Okay? Let's take a look at one more example. So here it says, your dear sister has loaned you $1,000 with the understanding that the principal plus 4% interest are to be repaid when you are able. How much would you owe her if you repaid the loan after 1 year, after 2 years, after 5 years, or after 10 years? So there's really 4 different answers we're looking for here. So again, because we're looking for the total amount that we would owe her, we're going to be using the A equals P times 1 plus RT equation. And in this case, we can see that the 1,000 is the starting amount. That's how much we're borrowing from her. And we would always be using the interest rate of 4%. So 0.04 is always going to be in this problem. What's going to change is the T value. Okay, so let's just make ourselves a chart here so we can keep track of what's going on. So I'm going to have T as my independent variable, and then A is going to depend on the time. So how much I owe her will depend on how long it takes me to pay her back. So we have 1 year, 2 years, 5 years, give myself a little bit more space there, 5 years, or 10 years. Okay, so we're just going to use this equation. We're going to substitute our different numbers of years in for T and work this out in the calculator. So for 1 year, I would end up owing her $1,040. So $40 extra on top of the $1,000 that I borrowed her. If it took me 2 years to pay her back, then I would owe her $1,080. If I plug in 5 for T and work it out for 5 years, then I would have to pay her $1,200 back. Now, what would I need to pay her if it takes me 10 years to pay her back? Again, pause the video for just a moment and answer this question on your Zaption. How much would you pay your sister back if it takes 10 years to pay her back this $1,000 loan? Well, if you've punched in the buttons correctly, you should have gotten a total of $1,400. So you can see how, obviously, the longer it takes you to pay her back, the more you will have to pay her back because the interest is going to accumulate. Now let's just take a quick look at what that looks like graphically. So on the x-axis, I have my time in years, and on the y-axis, I have the amount I owe her. And you can see here I have a break in the graph because I really don't have to start anything less than 1,000. And so we're starting here at 1,000 and then going by 20s up to 1,400. So what I borrow from her is the 1,000. That's right there. Okay? In 1 year, we had 1,040. So that's going to be right about there. In 2 years, I would owe her 1,080. So that's going to be right about there. In 5 years, we were up to an amount of $1,200. So that's going to be about there. And then in the 10 years, we were up to 1,400. So that's going to be about there. So if we connect these dots, what type of a function do we end up with? Pause your video one more time to answer this question on the side, and then return to this to finish our video. So if we connect the dots, we should fairly easily see, oh, that's not very good. Let me try this. Let's see if I can put a line in here and see if I can get it to go fairly straight through these points. All right, that's not too bad. So the idea is that we have a very linear looking graph here, connecting all of our points for all of the different amounts that we would have to pay her back depending on how much time it took. We end up with a linear function. Now we'll talk more about this in the upcoming lessons, but this is important to keep in mind that with simple interest we end up with a linear function. Okay, so I think that's a good introduction to simple interest for today, and we will be using this idea to get into some other types of simple interest problems when we get together in class. And so until then, have a good evening. We'll see you in class.